Okay, welcome to ECO311. Okay, for this module, please first go through the prescribed chapters. I rely on you to make an effort to read the prescribed chapters and then go through the lecture speech notes or the study guides before you watch the videos. The videos are not meant to give you the comprehensive lectures, but the intention of the video is just to highlight the key areas, okay, that you must take note of. Okay, and for this module, there are a lot of in-class exercises, and then for some questions, I provided you the memo answers, and then for the other questions, I discuss in details in the study guide. Okay, so for the first chapter, we will do first lecture, sorry, we will do a quick recap of the ECO242 work. So please go through the study guides, and then you are going to see a lot of revision questions in the study guides, or just in case you totally forgot how to do these types of statistical analysis questions. For instance, confidence intervals type questions on the PRF parameters. If you no longer remember the difference between SRF sample regression function and PRF population regression function, I'm going to refresh your memory later. But in the study guide, you will see revision questions on confidence interval. And then you would also see some questions on confidence intervals on the variance of error terms using the chi-square distribution. So please follow the explanation and use the correct distribution table. Okay. And then the last type of revision question relates to hypothesis testing. Remember, there are three types of hypothesis testings involving T-table: two-sided, one-sided left tail, and one-sided right tail. Okay, and then in the second video, I'm going to refresh your memory further on hypothesis testing questions. Okay. But now I can go through the lecture slides. And again, as I mentioned before, I'm not going to go through every single slide. This is not the intention of the videos. Okay. Okay, recap of ECO242, chapter 0 to chapter 6. Some friendly rules again. I rely on you as a student, a mature student, to follow the rules. Okay, check the notices on eComfort and so forth. Read the prescribed chapters. Okay. Okay. Definition of a successful student, and remember, for this module, from my side, I don't want to only teach you economics knowledge. I also want to influence you to develop the right soft skills or graduate attributes. Then you can survive and succeed long term in the labor market. So look at these attributes like being honest, humble, polite, punctual, hardworking. Aren't these very important traits we should all develop to be a good human being and then survive well and win respect at work and in our personal life? Okay, so sunrise or sunset on your economic studies, you decide. Remember, you are an adult now, at least 18 years old. You have to make your own decision about your life as a student or as a human being. Okay, chapter 0, introduction. Okay, remember econometrics, despite being a highly quantitative module, it still involves economic theory. In fact, theoretical thinking always comes first before you make the decision later on how to run the regression model, which explanatory variables to include, and so forth. We always start off with theoretical thinking. But an undeniable truth is that econometrics involves mathematics, statistics, and then computer software. So last year in ECO242, you mastered the basics of Excel, and then for ECO311, you are going to learn eViews, okay? And then in eComfort, I uploaded the legal and free downloadable version of eViews 3, which is quite an old version from 20 years ago, but it is more than enough to cope with undergraduate econometric analysis. So after you download the eViews 3 installation file, which is in zip format, you must unzip the folder, then you follow the instruction sheet on eComfort, then you should be able to install eViews 3 on your computer or laptop. Okay, the 8-step methodology, I'm not going to go through that in detail. Refer to chapter 0. Okay, I'm not going to ask questions on the A-step methodology in ECO311 because we already covered this A-step methodology quite comprehensively in ECO242. Okay, chapter 1, just recap on the nature of regression analysis. So in case you can luckily interview the full population, remember the big N stands for population, then you can derive your PRF, population regression function. So this part means expected Y value given X equals to a particular value. And then this is your constant B1, B2 is your slope parameter. Okay, but the relationship between X and Y is inexact. This is why error term exists. So error terms exist, and then it actually stands for the difference between actual Y and the expected Y. Okay, and then for this module, just like ECO242, Y, I will keep mentioning the term dependent variable. And then for the X, sometimes there could be more than one, especially for this module, we will move on to multivariate regression. So there will be more than one explanatory variable. So I'm going to refer it to either explanatory variable or independent variable. Okay, I can skip this one. I think it must have been covered nicely in ECO242 just to give you an example of the graphical sketch of a PRF, population regression function, and then the difference between the actual Y and the expected Y value. So just a random example for this. I think this is a regression to look at the relationship between study hours and marks. So look at this student. Actual observation when X study hours equals to 3, the actual Y, the actual final mark is 47. But then, according to the PRF, when X equals to 3, the expected Y value is 46. So you see the difference between actual Y, 47, and the expected Y, 46. So the difference is 1, and which gives you the error term. Okay, chapter 2. Okay, remember in real life situation, it is unlikely for us to interview the full population due to 2 reasons, time and budget constraint. Okay, therefore we would only interview a sample of people actually. So I think I can skip these few slides. Reasons for the error terms, I'm not going to go through that anymore. Okay, if you totally forgot the reasons why they are error terms, please refer back to chapter 2. Okay, now I want to move on to sample regression function. I think I already mentioned the time and budget constraints. So in reality, we can only interview a sample of people. Sample, we use small n, and then we derive the sample regression parameters, and then for these parameters, we have to put the head. Okay, so in other words, these are sample regression parameters. B1 head, my constant, B2 head, slope parameter, and then U hat stands for residuals. Remember in PRF, U without a hat stands for error terms, difference between actual Y and expected Y. But for SRF, U hat stands for residuals, which means the difference between the actual Y and estimated Y. Okay, then chapter 3. This is a mathematical example to derive the sample regression parameters. OLS method, ordinary least square. So we want to minimize the sum of square of residuals in order to derive the sample regression parameters. Okay, so at 3rd year level, I'm not going to ask you to do these calculations. In fact, I will give you the whole sample regression function information, the parameters, each parameter, standard error of each parameter, sample size, R square, and you are going to learn a new concept called adjusted R square and even F statistic, okay, for multivariate regression. And then the statistical properties of regression line, okay, they are still applicable for multivariate regression. So let me pause for 30 seconds just in case you don't remember these statistical properties. Okay. And then the assumptions of CLRM, classical linear regression models. I'm not going to go through all these assumptions again, but for ECO311, we are going to learn a bit more on assumption number 4, homoskedasticity, heteroskedasticity. And then we are going to have a chapter on autocorrelation, which is about the relationship between the error terms. Okay, and then number 9, we are going to have a chapter that looks at collinearity or multicollinearity, which is about the possibly strong relationship, linear relationship between the explanatory variables. Okay, and then the OLS estimators are linear, unbiased, efficient, and consistent. In case you don't remember what these 4 concepts stands for, let me pause for 30 seconds to refresh your memory. So please go through this slide. Okay. And then I can skip this one. Okay, R square for bivariate regression. Keep in mind the square root of the R square actually gives you the correlation coefficient, but only for bivariate regression. And R square has a range of 0 and 1. R square actually means the goodness of fit of your regression. Okay, this is an example. I can skip this one. Okay, I can also skip this one. So for multivariate regression, the focus of ECO311, keep in mind that the square root of R square no longer means correlation coefficient. Okay, this is not applicable for multivariate regression. Chapter 4, there are 2 more assumptions of classical linear regression models. Okay. And then chapter 5, okay. Hypothesis test, confidence interval and hypothesis testing. This is what I mentioned right at the beginning. In case you no longer remember how to do these questions, look at the revision questions in the study guide. Okay, so confidence interval of variance of error terms, which involves chi-square distribution. Hypothesis testing, remember there are 3 types of hypothesis testing involving T distribution, 2-sided, one-sided right tail test, and one-sided left tail test. This test about the normality of residuals, we're not going to do it anymore for ECO311. And then chapter 6, okay? Different functional forms, linear model, double log, log log, reciprocal model, polynomial model. I'm not going to ask questions on the different functional forms anymore for ECO311. Okay, and then R squared, this is important, just in case you no longer remember. We can only compare the R square of 2 regressions if all 3 criteria are met. Sample size must be the same. Number of parameters K must be the same. And then finally, the Y, the dependent variable, must take the same form. So if we look at this example, the 6th regression, right from the beginning, I can see it is impossible to compare the first regression with the other 6 because you already see for the first regression, the Y takes a different form. You see the log of Y. But for the other 6 regression, Y or the marks here are all in linear form. So we can say goodbye to the first regression, not comparable with the others actually. Okay. And then you can also notice the sample size is different. For the second regression, it is 30, but it is 20 for the other regression. So I can say goodbye to the second regression. It is not comparable with the others. And then also, if you look at the 7th regression, it is a multivariate regression. K is equal to 3. Do you see 3 parameters? So it is not the same as the others. So we cannot compare regression 7 with the others. So in conclusion, it is only possible to compare regressions 3, 4, 5, and 6 because Y takes the same form, linear, same sample size, 20, same number of parameters 2. Then now it is possible to compare the R square of regressions 3, 4, 5, and 6, and then the R square is the highest for the 3rd regression. So we can conclude that out of the 4 regressions, 3, 4, 5, and 6, regression 3 has the best goodness of fit. Okay, you might ask a question, what if we really want to compare 2 regressions with different numbers of parameters or different sample size? It is possible, but the answer would be we have to rather use a different indicator, which is adjusted R square, which you would learn in chapter 7. So that's it for chapter 6. And then the next video, we will redo some of the hypothesis testing.